We use extrude a lot. Simple function. However, extrude has lots of embedded function allow us to create our parts more easily. Right. So example this one. Let me say connected curve. So if I'm going to say value, you can use the value to start and use end, right? Limit, right? It determines from where to start and from where to end your extrude, right? So if I'm going to choose, usually it's going to be 0, then it will start right, okay, from your sketch plan, okay, sketch plan, right? So however, if you give some value 10, for example, what will happen is it will start the plan which is parallel to the sketch plan, right? Sketch plan. And what's happening? Then it will be 10 millimeter away from your sketch plan and in the specified direction. Okay, in the specified direction, you can actually specify direction, not necessarily parallel to your sketch plan. Okay, so you can examine this function later. If you're going to give negative value, then it will go to other direction of your extrude direction. Okay, extrude direction. So you can see here, right? So if I'm using this one, then it will go two direction. One is from here to here will be 50 millimeter, and from this to here will be 10 millimeter. Okay, 10 millimeter. And what's happening is it will be in total will be 60 millimeter. So let's do an analysis. Say simple distance from the top to the bottom. It will be 60, right? So exactly. Oh, we cancel this one. I don't want to save this one at this moment. You see this one. So from here to here, right? From start to the end, it will be 60 millimeters. Okay, all right. So you can see that. All right. So let's see one thing here. If we only extrude in one direction, what will happen? And we can see we are not consider the booling at this moment, right? If you have other bodies, then you can operate booling operations, right? Booling operations. However, we only have one here, and we're not interested. We're not focused on boolean operation at this moment. So when you look at the draft, okay, we have another one, draft. Okay, so what's happening is we only have 1, 2, 3 options, none, which is by default. And you can start from start limit, okay, start limit whenever you start your extrusion, right? Or from section. From section is from your profile. Okay, so if you're looking at starting limit, in this way, it will be same. Let me say exaggerate, right? So you will see it clear. Okay, so you can see here it's from here. And if I'm going to use section, what will happen? Nothing happen, right? So however, if I'm going to say 10 millimeter, what will happen? Okay, 10 millimeter. Right. So, and from section, you can see here from section. So you can see it will start count from here to here. Okay, count from section, your sketch plan, right? So if you're going to use a start limit, then you can see the bottom. The bottom will be equal to your sketch. You understand? Is that clear? Is that clear? Everybody? So you can see this by using, say, front view, right? If I'm going to start limit, right, then you can see my bottom equals to the sketch, right? My bottom equals sketch. However, if I'm going to use from start limit. You can see here. You can see here, right? Then it just start from this. Okay, it start from this. So let me say extrude again, right? So same as this one, and I'm going to say no offset. The draft, right? The draft. So 10. Okay, and the same here. Draft will be start from section 10 degree, and let me see, and this one's okay. Uh-oh. Cinco. 10 millimeter. 10 millimeter. That's right. Okay. So what you can see here. Let me make this one. No bullying, right? So no bullying. Okay. I don't want to make this one unite with this one. Okay. So I'm going to make this part. Okay, you can see here, right? You see the difference, right? Okay, you can see the difference. This one, we have same, what's it called? Limit, right? We have same limit. However, we choose different draft starting sections, right? So pay attention, right? Pay attention. When you use this one, when you use this function, you need to know exactly what you're doing, right? So this is very important. Okay, let me save this one. You can save this one for a moment. Okay, so when we only extrude in one direction, then the draft, okay, one direction. And when we see the draft, we only have 1, 2, 3 options. Actually, 2 options, right? No draft. Okay, default. We can. Okay, so let me. One direction. Okay, this extrude in one direction. Okay, so let me save it and let me press it. So, however, it allows us to extrude in both directions, right? Both directions. So -10, this one, this one, and then now when you see this one, oh sorry, 10, -10, sorry, -10. All right. So once you see extrude in this direction and this direction, what's happening? You can have three more options for your draft. Okay, for your draft. The first one, symmetric angle. That means in this direction, let me. In here it's 10 degree. Okay, and the backward you can also have an angle. Okay, so asymmetric, right? Asymmetric. You can choose different angle in either of this direction. Okay. Okay. The forward angle and forward angle, front angle, and back angle, right? Back angle. Okay. You see that? So if I'm going to use 10, then it will be actually symmetric, right? This is the general. This is general, right? However, you can use this one. Actually, use this one. By using this one, you can control. You can control the. You can control your angle by just putting anything, right? However, there are two special case. Okay, two special case. This one, okay. Understand. You need to understand this two option can be made. Okay, can be made by type appropriate input angle here by doing this. Okay, by doing this, right? By doing this. Okay. Angle. Okay, there's an angle, right? There's a multiple, right? Multiple angle, right? So you can see here multiple angles. All right. So multiple angle means in each of this um each of this face, you can use different angle. Okay, you can use different angle, right? Okay. So anyway, we're not consider this at this moment. We just consider single at this moment. All right. So 10 angle, 10 degree and 10 degree in both sides. So it will give you this result, right? Okay, the symmetry, okay, the symmetry, right? So you can see here, all right? So if I'm going to use 10, you will see they're exactly the same, right? Okay, they're exactly the same, right? So, okay. So, however, if we would like to make symmetry, then the same as front angle and back angle equal, right? Equal, right? So you can see here, if I'm going to give you 55 or 50, sorry, then it will be symmetries. The symmetry plane will be your section plane. Okay, section plane, right? So it's pretty straightforward, right? So you just use the same angle, right? Here's another one, right? Match the end. Okay, match end. So what does this do? It will gives you it will make the top area and the bottom area always equal. Okay, always equal. Say I'm going to put this, no matter what's the value in given here, right? So let me 10. All right. So you will see this area will be equal to this area. Okay. Okay. So match section. Okay. Matched ends. This end and this end will always equal. That's the option being given. Okay. Right. So and let's say look at the front, right? Front view. Say we can do a measurement. Okay, so analyze from this point to this point. Okay, and hit apply. So analyze or measurement, sorry, measurement, right? So you can see here information. Okay, it is 102. Okay, 102, right? So I'm going to measure the bottom. Okay, measure. Measure this. Oh, sorry. This one's supposed to be here. And apply. you can see this one information. I should have same as this one, right? You can see they're exactly the same, right? Okay, so then by doing this, you don't need to do calculations. Okay, the system do the calculation for you. All right, do the system calculation for you. No matter what the value you're going to use, right? Very odd number. Okay, very odd number. What happen, right? Okay, what happen is they always going to match. Okay, the top area and the bottom area will always match. All right, so that's the basic application you can use for extrude. Okay, I'm going to save this. Okay, let me say new direction. Draft. Okay, so me as this one. Okay, we're going to look at the draft again, right? Draft again. Okay. We can do draft while extrude itself. Okay, we can also use draft. Okay, we can also use draft if we have the extrude body already. Okay, so let me do this again. This time I'm going to use a region boundary curve to extrude, right? So this one, I'm going to make a, excuse me, I'm going to make a part like this, okay, with outer wall and internal wall, right? So I'm going to just use 0 here. Okay, this time, okay. And I'm going to hide my sketch, so make my screen more clear and hide my data coordinate system. Also, you can see here, here's my parts. Okay, here's my parts. And I'm going to say use a draft. Okay, use a draft. Okay, so this time I'm going to, again, I think 10 degrees is a little bit too large. Okay, anyway, so okay. Stationary, right? Stationary face it will be here, and you can select multiple stationary face. Okay, so I'm going to select the bottom as my direction face and specify vector. It will be in Z direction. Okay, vector will be in that direction. So okay, all right. So the faces 5 degree. Pay attention. Here's add a new set, right? New set. So if I'm going to select all this one, this one, this one, then you can see I have 4. Okay, I have 4 walls being selected, and it will be have exactly the same draft angle with the bottom as reference. Okay, if I'm going to apply, it will look like this. Okay, anybody tell me what's the angle between and the inner wall? Can anybody tell me? Can anybody tell me? How many degrees? Let's do a quick measure, right? So we're supposed to have 5 degrees between this wall and outside wall, right? Each of this. Okay, so let me measure. Okay, simple angle in here and here. All right, you can see. Okay, correct? The wall between here and here is 175, which is 5 degree, right? 5 degree. Okay, so same as this one. Okay, so I'm going same as those, right? So, all right. What if I include inner wall this time? What if I include inner wall this time? Okay, so let me right click. Okay, so this time I'm going to include this wall. Okay, and hit OK. What happened? This one goes to this direction. Okay, instead of parallel to my okay, instead of parallel to my out wall. Okay, out wall. Right. So they're opposite. Okay, they're opposite. Right. Correct. Okay. So this is how it works. Okay, that's how it works. Okay, if you're going to choose inner wall and out wall simultaneously, then you will have a draft. You will have a draft angle which is in 1 degree, in one direction, and the outer wall in one direction, and the inner wall will be in opposite direction. Okay, right? So this is how it looks like. Okay, you can see this one inner wall is in this direction. Okay, right? And when we are doing mold design, then this operation help us to, if you are going to use symmetric draft angle for all the wall, then this will help you create the wall, create the draft very easily. However, let me say, press this one to see what's happening. Use another one. Okay, so steer. We use Z direction as draw direction, right? So and then bottom as our and this time, if you're going to use the angle different, inside and outside differently, then what we can do here, I just use one. Okay, what you can do here, you can add. Okay, add another set. Okay, add another set, and then say choose this one. Okay, choose this one, and this one you can see 5 degree, right? In the 5 degree, what I'm going to do, I'm going to say minus 5 degree to see what's happening. Okay, so and I'm going to see a preview. Just look at the right side and say I'm going to use wireframe edge. You can see here. Okay, not easy to see. Okay, you can see this one becomes parallel, right? Becomes parallel. Okay, that's different. Okay, right? So it automatically calculates the inner and outer surface. Okay, on surface, right? So you need to pay attention to that. Okay, pay attention to that. Right? So when you are going to design a mold and the draw direction, the draft angle is measured differently for inner dimension and outer dimension. Okay, inner wall and outer wall will be different. Okay, pay attention to that. Right. Okay, this is a wall. Right. You can create the draft the draft command can be embedded, okay, was embedded in this extrude command. So you can either extrude first and make individual draft after you create your extrude, or you can create extrude and with the draft angle embedded. Okay. Personally, I prefer to extrude itself and then make draft later on. For me, because it's more easy for me to control my dimensions, okay, and without make my extruded feature a failure. Okay, if this failed, then I don't need to modify extrude. I only need to modify my draft. Okay. However, if you are sure, okay, if you're 100% sure, you can this just one time. You don't need to edit your draft later. You can reduce the feature list on your part navigator. Then you can embed it in it. Okay. All right. Let me now let's see if we can we have degree of 5, right? We have degree of 5. So if we're going to just use 1 degree and hit OK, what happened is it's kind of difficult for us. Okay, so we can still see from top, right? We can still see from top because we can see the bottom edge is not aligned. Okay, bottom edges are not aligned. Then we know there's a draft there, right? However, if we just put asymmetric view, can you tell me exactly do we have a draft here or not, right? Even smaller, say we have 0.5, right? You can still see something here, okay? You may suspicious, right? So probably there's a draft here, but you're not sure, right? So if I'm going to put 0.5, what do you say? You don't know, right? You don't know, okay? So what we can do here, if you are not sure, and the geometry becomes complicated, of course we can measure, right? We can measure, okay? So of course we can measure. So from here to here, okay, we can see it's not 180. It's not 180. That means this is not parallel, right? This two is not parallel. So that means, yeah, it means there's a draft angle. However, you still don't know. You still don't know by measure this two, right? So probably you want to measure, say this one, using this one, right? So, oh, you know, 0.5 degree, okay? 0.5 degree between this bottom and the wall, okay? Right, so, and then you're going to measure this one, then a degree again, okay? So this is how you can examine. Of course, you can do that. However, if this becomes very complicated and a lot of surface there, what you can do, we have a tool here. So analysis. There's one called relations draft analysis. Okay, face shape, right? Face shape, draft analysis. Okay, draft analysis. If you don't see this one, you need to get analysis tab. Okay, so draft analysis. You can see the select faces or facet body. It not only can apply to solid body, but it can also can apply to a facet body, right? So, okay, so I'm going to select all of them. Okay, all of them, and then specify drawing, right? Draw. You see, by default, it's in Z direction. Okay, by default, it's always in that direction, right? So you can, okay, so and orientation vector draw direction. You can see draw direction, right? So you can specify vector. Okay, so for example, Z direction. Okay, so X direction, right? X direction. Okay, X direction here, but in our case, it is Z direction. Okay, so we can just use this orientation direction. Okay, you can use default if your part is in correct directions. Okay, so and then you can see here limit angle. So you can see if currently we set 5, right? 5 degree here, 5 degree here. Then it shows what? Okay, it shows the bottom is not the bottom is not the drawn direction, right? So which is expected. Okay, so when we draw it, then the bottom is not one. Okay, have the correct draft angle. Okay, but we're not to worry about this one because this part, the core, for example, the core will be drawn in this direction, right? So, however, this one you can see the 5 degree here, green 5 degree here, less than 5 degree, right? Less than 5 degree. So, if it's on the card, then it will either blue or red. Okay, so if we are going to put, you can see those are in 5 degree, right? Are in 5 degree? The walls are in 5 degree, right? So for are in 5 degree, then it goes to green, yellow, right? Yellow. Okay. So pretty straightforward. If we go to point 0.45 degree, enter, you can see all of them are in green, right? Are in green, right? So, all right, so they're good, right? So because sometimes you want to specify the minimum draft angle, so you can create your part without any problem, or reduce the drawing force, right? So if you have smaller draft angle, then the friction force will be increased as your draft angle decreases, right? So it might difficult for you to pull the part out. Okay, so and damage the surface. Okay, so you want to specify minima always greater than minima drawing draft angles, right? Okay, so there's some other depends on the shape. Okay, the more and more complicated this tool becomes more and more useful, right? So all right, you can see here the edges with edge blend have more evenly distributed wall thickness, right? Okay, and also the draft angle, reduce the draft angle, also help us to have the wall thickness more evenly, right? More even, right? So, okay. All right. So